Concentrate. This is the first question. Later on in the question series also I will give different models, but for practice purpose to understand to apply the concept, that's why I am solving some questions. The coil of a PMMC instrument has 60 turns and a former that is 18 mm wide, the effective length of the conductor being 25 mm. It moves in a uniform field of flux density 0.5 Tesla. The control constant is 1.5 into 10 to the power of minus 6 Newton meter per degree. Calculate the current required to produce a deflection of 100 degrees. Here it is given that 1.5 into 10 to the power of, this is 10 to the power of minus 6 friends, 10 to the power of minus 6 Newton meter per degree. Here Newton meter per degree is given, that's why you have to substitute, theta is also in degrees, you have to substitute. Here we want to calculate the current required. Students, we know that what is the deflection of a pointer? Theta equal to NBA by K into I. You have to substitute theta directly in degrees. Why, sir? It is given in Newton meter per degree, na? That's why you substitute directly in degree. If it is given Newton meter per radian, you convert degree into radian, then you have to substitute. That observation is important. Yes. How many number of tons it is given? 60 tons. What the flux density? The flux density equal to how much it is given, students? The conductor being 25 mm, 18 mm wide, then calculate the current required to produce the deflection for 100 degrees. Yes. Flux density of 0.5 Tesla. What is the area? 18 mm into 25 mm. Millimeter you convert into meter, 18 into 10 to the power of minus 3, 15 into 10 to the power of minus 3, not 15, 25. 25 into 10 to the power of minus 3. Yes. Direct substitution only. 25 into 10 to the power of minus 3 by spring constant is 1.5 into 10 to the power of minus 6 Newton meter per radian. 1.5 into 10 to the power of minus 6 into I. Then from this you have to calculate the current, students. Therefore, the operating current I equal to we can get approximately 11.11 milliampere. Okay, this is the operating current. That is the final answer. How to calculate that one, students? Finally, you can get that one. Then which option is correct? Option A is the right answer. Direct formula you have to apply. Theta equal to NBA by K into I. Clear? Next. See the one more question. This I am writing. Yes, friends. This is example 2. Yes. It is given that the PMMC having the coil dimensions of PMMC instrument having coil dimensions of that you have to write 15 mm into 12 mm. 15 mm into 12 mm. The flux density is 1.5 into 10 to the power of minus 3 Weber per meter square. 1.8 into 10 to the power of minus 3 Weber per meter square. You have to find the number of tons in a coil. Find the number of tons in a coil. Find the number of tons in a coil for a current of 5 milliamperes and at a deflection of 90 degrees. You have to find the number of tons in a coil for a current of 5 milliampere at a deflection of 90 degrees. Yes, simple, direct formula. Yes, friends. How to apply the formulas, that you have to concentrate. Direct formula, theta equal to NBA by K into I. Now the question is, theta is given 90 degrees. 90 degrees. But What is the spring constant it is given? The spring constant is, this is missing here. You have to take this spring constant K equal to, the value of K is given 0.14 into 10 to the power of minus 6 Newton meter per radian, friends. This is 0.14 into 10 to the power of minus 6 Newton meter per radian. Now this is given in Newton meter per radian, but theta is given in 90 degrees. You have to substitute theta is in radians. Then 90 degrees means pi by 2. All these values you have to substitute. This is pi by 2 equal to, how many number of tons it is given? That you have to calculate. The flux density is how much, friends? 1.8 into 10 to the power of minus 3. What are the coil dimensions? 15 mm into 12 mm. That is 15 into 10 power minus 3, 12 mm, 12 into 10 to the power of minus 3 by, what is the value of K it is given? 0.14 into 10 to the power of minus 6. How much operating current it is given? 5 milliamperes. That is 5 into 10 to the power of minus 3. Then from this you have to calculate the number of tons. Approximately we can get 136, nearly equal to 136 tons we can get, students. Okay, that is the final answer that you have to calculate. The current is 5 milliamperes. The deflection of pointer is 90 degrees. This is 15 mm into 12 mm, that you have to substitute 15 mm into millimeter equal to 10 to the power of minus 3 meters. Then the flux density is 1.8 into 10 power minus 3 Weber per meter square. Okay, that you have to calculate. Clear? See the one more question. Example 3 I am solving. Concentrate. Okay, like this, very simple to calculate, to solve any problem by using the torque equation, students. The coil dimensions are given. Direct writing data. The coil dimensions is, it is given that 40 mm into 30 mm, 40 mm into 30 mm. The number of tons is, it is given that the number of tons is 100. It is not 40 mm into 30 mm, friends. You have to correct this. It is given that 10 mm into 8 mm. Coil dimensions 10 mm into 8 mm. The number of tons equal to, the number of tons is 100. The number of tons is 100. The flux density is, it is given that 0.15 Weber per meter square. 0.15 Weber per meter square. 15 Weber per meter square. The current is 5 milliamperes. The current is 5 milliamperes. And it is given that the controlling torque, yes, the spring constant K equal to 6 into 10 to the power of minus 6 Newton meter per radian. Newton meter per radian. Okay, then you have to calculate what is the value of TD, what is the value of theta. This question is framed. Okay, 6 into 10 to the power of minus 6 Newton meter per radian. You have to calculate what is the value of TD and what is the value of theta. It's very simple. What is the solution for this one? First I am calculating deflecting torque. The deflecting torque. TD equal to NBIA. NBIA. How many number of tons it is given? There is 100 tons. Yes. The flux density is 0.15 Weber per meter square. The current is how much? The current is given 5 milliamperes, 5 in 10 to the power of minus 3. Yes. Area is 10 mm into 8 mm. 10 mm into 10 into 10 to the power of minus 3 into 8 into 10 to the power of minus 3. Then how much deflecting torque we can get, friends? Check it. The value of the deflecting torque, how much we can get. Okay, this is the 15, 75, 75, then 750, 750, 750 into 8. 750 into 8, that is, you have to take 6,000. 750 into 8 now. 750 into 8, that is 6,000. 6,000 into 10 to the power of minus 9. 6,000 into 10 to the power of minus 9, that is 6 into 10 to the power of minus 6, then Td equal to 6 micronewton meter. That is Td. Then what is Td? You have to calculate theta. We know that at steady state, Tc equal to Td, that is k theta equal to Td. Then from this, what is theta equal to Td by k, that is 6 into 10 to the power of minus 6 by, what is k? It is given 6 into 10 to the power of minus 6 Newton meter per radian. 6 into 10 to the power of minus 6 Newton meter per radian. Then how much we can get, students? Newton meter per radian. Theta equal to 1 radian we can get. We can get theta equal to 1 radian. Yes, students, this about different practice questions based on the deflecting torque equation of PMMC instrument.